Obtaining and processing DEM data, part 2. Getting difference, and that's partially based on the range of colors. If you look at the colors here, you'll see 1204 to 2771 versus 1217 to 3308. We've got these are elevation values in meters, and sometimes it's in feet. These are in in meters, and this one's a little higher, so we've got a little tonal difference in our color shading here. You can change some of this based on a little more advanced symbology techniques and stuff. We're going to avoid that for now to keep things simple. And what I want to do before I go on to is go back to the folder just to show you what the program created. I tend to do this a lot just for reference sakes. And remember, before we just had the .dem files in there, and you'll see some XML files which actually got created on just the one that we viewed with Art Catalog, because Art Catalog by default will create an XML file once it reads a file. That's basically where it's attempting to build its metadata file. And you'll see some AUX files which were created during the conversion, and basically you see a few folders that were added here, and one for each of the names that we gave the raster data, and then an info folder, which is part of the grid file formatting. If you open one of those folders, you'll see some kind of strange looking files. If you sort them a little bit, you can see the sizes in there and the names. We're not going to go into each of these for now, but these are basically files that get created by ESRI that are in sort of more of the old ArcInfo type format, which was back when they created the grid format. And the program uses these files to build our grid file in the art map. We're not going to go into any more than that. I just wanted to show you that there are folders that are built there, and also to point out that this is where it becomes sort of problematic if you try to move these folders around later on. You can real easily not move all of the folders you need to and create problems. So it's real, if you ever need to rearrange your folders, which hopefully you've done a good job of setting up subfolders in advance to where you don't need to do that. But if you do, then use Art Catalog for moving things around, and it will try to move all the accompanying data that goes with that particular file for you automatically as you move things around. So let's go back to our art map. And let's see if we can rearrange this a little bit to where it looks a little more pleasing to the eye, and you can begin to see some of the real power and potential of the DEM models. So what I want to do is first change the color shading on it, and we'll use a similar palette for each, and that might help us account for a little bit of the tonal differences here. So what you can do is click on the Symbology here. I left clicked once, and then I've got this color ramp here. Now I could go through that color ramp and pick out different colors, which is fine, but one of the things they've done, if you'll right click on that, right on top of one of the color ramp itself, you can switch it from graphic view, turn that off, and it will switch it to name view. And then you can select the dialog again, and you should see, if you scroll down, you'll see a couple elevation templates that they've set up for you. Now you can vary this to your heart's extent. You can add and create your own color ramps, and lots of things you can do with Symbology. Some of the basics of Symbology is explained in your Getting to Know ArcGIS book. What I'm going to do for this example is pick the elevation 1, which I kind of like that color pattern myself, and I'm going to select that one, and you see how it changes it on that one. Now let's do half dome. And let's do the same thing, and we'll pick the same color ramp, and you'll see they match up much more nicely in this case here. There still is a little bit of difference. You can tell looking at the colors. It's not exactly the same, which it can be a little aggravating, and you might want to adjust that, and we'll do that a little later in another lesson. You can probably do that, but for now let's go ahead and save our project, since we've done quite a bit of work. We don't want to take a chance on losing anything if something were to crash on us. And I'm going to save that into the working folder I set up for EXER3, and just into the base of that folder. I don't need to put this in the DEM subfolder. I'm just going to call it DEM exercise. And now let me show you a couple things you can do with this data besides just some pretty colors. One, we could load some of our DLG data in, which we can do that here in a few minutes. Let's go ahead and process this with Spatial Analyst, which is one of the extensions back when you installed ArcGIS that you hopefully installed with the program. When you were prompted, and I think I pointed out earlier in the semester, to go ahead and accept all the extension trial periods that the program gives you when you installed your student evaluation version. And the first thing we want to do is make sure we've got Spatial Analyst extension turned on. So we'll go to Tools and go to Extensions, and it should take us to a drop down of all the various types of extensions that we have loaded. And notice Spatial Analyst is here, but it's not turned on. So I'm going to enable that and say Close. And you initially don't see anything that happens on your desktop, and that's because we now have to turn the toolbar on for that extension. So let's go to View. I don't know why Esri doesn't put all these together, but we go to View for that, go to Toolbars, and in the drop down there, scroll down to Spatial Analyst and select that. And you should see a toolbar pop up on your desktop, which we can drag and embed it up here into the top menu just to get it kind of clean up our space there a little bit. And one thing to remember is that this toolbar, now that we've turned it on, I'm going to leave my extensions turned on by default, which if I close ArcMap, it will remember that I had that turned on, and it will automatically enable it in the future session. So unless I turn it off purposely, it will stay on. But remember that you have the two steps there. If you ever see this dialog on here and you're running some of the things that we're going to do in a moment and it doesn't work, or you don't see the layer option here, make sure that your Spatial Analyst extension is enabled over there in the Tools menu. Basically what I'm saying is that the toolbar will still come on even if the extension is not enabled. So they're not a one-to-one relationship there. It's a little confusing and something that would be nice if Esri would change that in future. But for now, just remember you do have to have both the extension turned on and the toolbar enabled to actually work with it. The other thing to remember is that you have a target here in the layer drop down, and it defaults to the top layer in your contents. We always want to make sure that that is set to the one we actually are processing, that we think we're working with, because this is the one it will actually process any of the Spatial Analyst functions on as we're running it. So we'll go ahead and leave it set to the Yosemite Falls for now. And what I want to do to start with is I'm going to create what we call hill shading effect, which will let us get to more of a 3D type of view for this particular set of files. The way we do that, click the drop down for Spatial Analyst, and of all the options you have here, go ahead into the Surface Analysis. And in Surface Analysis, go ahead and select Hill Shade. And it brings up a little dialog. It's noting which input layer it's dealing with, which is the Yosemite Falls. And the azimuth and altitude, what this will do is this will simulate an effect that you would get if you were looking down from an airplane onto that surface, and we're simulating the angle of the sun and the altitude of the sun above the horizon. And the program defaults to this azimuth of 315 degrees and 45 degrees for the altitude, and I find that that's nearly always an excellent choice. So let's accept that for the default. If you were doing some really detailed modeling and wanting to simulate things at different times of the day and things like that, you might tweak these a little bit. But for now, I would encourage you to just leave them as the default. It's one less thing you have to fool with changing. So we'll leave that there. The Z factor, similar to what we had back there when we created the initial DEM model. Let's leave that to 1. The cell size, it defaults to 10, which is the 10 meter size, which was the source file that we downloaded. So let's leave that to default as well. And now it's going to store it here in a temporary folder, which is literally your temp folder, which is embedded in your My Documents and your local settings, and it's very hard to find. It does this by default because it's assuming you might want to create more than one hillshade before you accept the one as a final and so forth. I like to change this while I'm thinking about it right off the bat and put it into my working folder. Usually I'll store it right there with my DEM folder because it's all, to me, related to DEMs. If you wanted to be real organized, you could abbreviate hillshade and put a subfolder in your DEM folder, I guess, and store it there to separate it from other layers. But just note that because this is a grid file that it's going to create, similar to what we saw before, it's going to end up creating several subfolders. That includes an info folder, and to me it's just cleaner if you can let that default to the root of the working folder that we use for the DEM file itself, because then it doesn't have to recreate as many subfolders, and it makes it a lot easier to keep up with. So what I'm going to do excuse me, for now is go ahead and route it to that folder. Back in our working folder, the online exercise 3 in DEM, and I'm going to let it route into this folder here, and I'm going to go ahead and call this YOSE Hill. So it's 8 characters or less, and I know from the first part that it's related to the Yosemite, and we'll save that and then say OK. And it will process for just a minute, and then it creates a real interesting kind of simulated relief model as if you were looking down from an airplane. Let's go ahead and do that with a half dome. And notice, even though I selected it here on the left, it's not selected up here. So let's go ahead and select this one to half dome. And now let's run Spatial Analyst, do the same thing, the hill shade, and leave everything to default, except remember to route it to the folder. It remembers the subfolder we used, so all we have to type in is our name, and we'll call this half hill. Not hail, but hill. And process that. And there it creates for the simulated hill shading effect for the lower quad. Now let's drag both of these hill shades to the bottom of our contents list, so they'll be actually turned on below the DEM models. And now what we'll do is we're going to create a little bit of transparency effect in our DEM model, so that we can basically still have our colors but see through those colors into our hill shade. And that's what's going to give us sort of a 3D type of look to this setting. So let's go ahead and process Yosemite first. Now right click, go to Properties, and I want to go to the Display tab. And in Display, you'll notice right in the middle here is a transparency option. Let's set that transparency to, let's start with about, let's say 45, just as a default. And instead of saying OK, let's move it over here where we can see, and we'll apply it so we can see the effect that it gives us. And I like that, so I'm going to say OK. And you can see how we're getting much more of a 3D type of look now. And let's go to half dome and do the same thing. Set our display to 45 and say OK. Now we can zoom in, and now one of the drawbacks we're getting is very nice, by the way. You can see the sort of the relief now much better, and you've still got your color shading, so we know the higher elevation jumps out from the lower elevations. A lot of relief difference from the floor to the top, floor of the valley up to the top. We have a line where these are joining, and this is part of the artifact of where the two quads are butting up against each other, and some of this is overlap effect. And right now we don't have time to go into mosaicing and stuff, but we could get rid of some of this line by doing some other processes that we're not going to do in this case. This lesson's really just designed to show you how to create the DEMs and do a little bit with the DEM models, but that's why we have the line there. So for now, let's just go ahead and leave that alone, and we'll accept that for now. But and I point that out also because there was also, for a time, there was a problem with the DEMs that came from the USGS had a line in there because they were shifted just a little bit in the processing. Depending on the source of where you get the DEM, sometimes that still exists. So this actually line might be because of that as well. So that's our DEM. There's our hill shade effect. Now we could go ahead at this point and load some of our other data that we created in the previous exercise. To save time, I'm going to go ahead and show you a couple other things that we can do with the DEM models first. Let me zoom out a little bit. Remember, we're working in UTM meters, and our datum got set on the fly to 1927 because that was the source of these DEMs when we loaded the project. So any other layers you pull in, you want to make sure their datums are in 1927 at this point. Now, one of the things you can also do is you can go into Arc Catalog. Be sure to save and close ArcMap before you did that, though. But you could go into Arc Catalog, and now that we've processed these layers, you could actually reproject the DEMs. Actually, the way you'd have to do it, I think, is you have to reproject the DEMs as the grid layers into a 1923 datum if you wanted to create two sources here to work with. But again, now that you have the knowledge of how to do reprojections, you could actually do that. For now, I'm going to save some time and leave these set into 1927. I'm not going to really pull any other data into this project so we don't confuse things. But wanted to show you just a few other things you could do with the DEMs at this point that could be potentially useful to you. We've created the hillshade effect. One of the other things you can do, if you go back, I'm going to set this back to Yosemite Falls. If you go back to the surface analysis, there's a contour option here. If you select that, you have an option here to put the surface in. You've got a contour interval option, a base contour, a Z factor again, which we'll leave at 1, and a storage, which stores them to that temp folder by default. So you'd want to do several things here. One, you can change that interval. I would be careful about setting it too small, but let's go ahead and try it at 40. But before I do that, actually, let me show you another little trick you can do here. Remember that we're dealing with meters in this case, and most of your topo maps, if you really wanted to get the contour intervals, a lot of times you're wanting them in feet because feet tends to be just more widespread, more common, and most of us tend to relate to feet a little better than we do meters. So what you could do is you could attempt to approximate the contour interval that would be used on the topo map by converting the meters into feet. So basically what we're asking here is if we've got a contour interval, it's going to use meters because we can't switch it to feet. But what we could do is we could basically say how many meters would we be dealing with if we wanted to get it into feet. Okay, so if we wanted to use 40-foot contour intervals, for example, then what we basically need to say here, or answer here, is how many meters is going to equal 40 feet contour intervals. So the way you would do that is 3.28 is your conversion factor. Basically, there's 3.28 feet in 1 meter. So we can basically say for 40, if we've got 40 feet, how many meters would it take to make 40 feet? So let's put 40 into the calculator and divide that by 3.28. And we come up with 12.195. That's basically 12.195 meters would equal 40 feet. So that should give us a 40-foot contour interval approximation. So let's put into this contour interval, let's put 12.195. And then for our base contour, I'm going to leave that at 0. And that's, we'll let that default to 0. The Z factor, we'll leave that to default to 1. And we'll basically only change then our output features where we have that file stored. We want to make sure it's not stored in the temp folder, but over in our DEM folder where we've been storing the other information. So we'll put it there, and let's call it TOUR 1 for contour 1. And we could call it, contour 40 if we wanted to know it's a 40-foot interval, whatever works for you there. But I'm going to leave mine at contour 1. Save, and notice what it's going to create from the dialog there it's a shapefile. So it's basically going to convert a shapefile out of this raster file for us. And what's really nice about this is if we now turn off of those underlying layers, you can see it a little bit better. You see that we end up with a contour map. And this contour map is very similar to what we would have obtained if we had the hypsography data. Remember, we had hypsography data that we looked at as part of our DLG data. And the hypsography is very valuable, but it's not always available in all cases. And as I'm zooming in, you can see it's even showing the detail where it drops down into the valley quite well. And if you zoom in, you'll see it actually has those contours interval. And this is the nice thing about this is it's a vector-based file. It's a shape file, so it's smaller, okay, as compared to a raster file. It gives us a way to get at contour lines when we don't have them available through the use of a hypsography layer. The only other way we could have got to this contour interval that I'm aware of would have been through some selective symbology in our DRG file. Remember, the DRG is your basically topo map scan. We could have turned all the colors off except for the brown color that exists on those, but you would end up with a mixed bag of contour lines that are very blocky because they'd have the raster look to them. And in this case, we've got a nice smoother vector file. Now, this vector file was approximated from a 10-meter grid, and it's surprising actually how close this is to a DRG file. So one of the things you might want to do for an exercise would be load your DRG file behind this and compare this file with the topo lines on the DRG file, especially now that we've converted it to feet. Remember, if you don't do that conversion into feet, you won't get the same look. So they won't line up one-to-one. But this should line up pretty close to one-to-one with the DRG file, given that we were at a 10-meter sampling resolution. So it comes out quite nice. It's a good substitute to a hypsography layer when it's not available. And if you look at your attribute table, it also has the contour interval in there. And that contour interval is in meters right now, but we could easily convert that into feet and have a record in our table for that by adding a field to this table and multiplying this field by 3.28. And right now we haven't talked a lot about how to edit the attribute table, so I'll leave that for a later lesson, but it would be easy to get there. So we have a very detailed file here with a lot of contour lines in it, and a great substitute when we don't have the hypsography available. So another good use of DEMs. So we've looked at hill shading, we've looked at creating contour lines. Now let's look at a couple other options. If I go back into the Yosemite just to use it to be consistent, I can go into Spatial Analyst and select Surface Analysis again, and I can also create a slope map from that. And the way you would do that, when you select it, it wants to know if you want your slope map to be in degrees or percent. So let's just leave it to degrees for a default. We're just trying to keep things simple. Let's just accept everything else in here at a default level, except for the output folder. Instead of a temporary folder, let's again route it to our working folder. And we'll just call this YOSSE and SLOP for slope. And save. And say OK, and it very quickly goes in and creates a slope map for us, which is very nice for a lot of different types of analysis that you might be doing, where you want to know how steep an area is. And it automatically assigns this color palette to it, and it assumes you're going to want the red colors where it's steeper and the green where it's less steep. And you can see in degrees, and again we could have done this in percent, but in degrees, you've got a 10-meter cell-based raster image now that shows to that 10-meter resolution the relative steepness of slopes in these areas. And you can see where the drainages are running in. It's detailed enough that you can even see the actual drainages coming into here. You can see where it drops off the cliff area. And if you turn your contour, since we had contours above it there, we can turn our contours to sort of verify some of this information. And you can see in areas like this, where I'm moving the mouse now, where you have wider space contour lines, you have more green colors where it's less steep. In areas where the contours are very close together, you've got the darkest reds where it's the steepest. So it is logically doing what we would expect it to do. And we're verifying that through our use of our contour map. So you can see you can get a lot of very different looks here. You're hopefully beginning to see the potential usefulness of some of this. I'm going to turn this back off. Now let me show you another type of image you can create. and that would be an aspect map, which aspect is basically simulating from the source material the direction on a compass from 0 to 360 degrees that the surface is facing. So if you were lying down on the surface of this area looking up at the sky, the direction you would be facing is what this is going to give you. So you're using the Yosemite to start with as a default. Again, we've got a cell size set to 10, leave that to default, and let's route it from the temporary over to our permanent like we've been doing, and this time we'll call it YOSE, and we'll just call it ASPT for aspect. Save. Okay. And this time you get a real colorful map here. And to be consistent, let's go ahead and zoom in and turn our contours on again. Let's just zoom in to this area here. And if you notice first, notice here it's on the symbology that it's using, it's giving you a very detailed aspect output, ranging from flat areas to areas that face north, northeast, east, southeast. So you're getting the cardinal directions as well as the in-between, the directions as well. And it gives you the compass bearing, basically, of what it's considering north. So we know for north it's using from 0 degrees to 22.5. Then it switches over to northeast until it gets to 67.5. Then it will consider it east. Notice it's not due east, it's just an easterly direction with the various degrees around that direction included. And let's and this can be a little confusing at first, but if you turn the contours on, it helps a lot. And with our contours, we can see basically that you can see the areas where we're looking at the ridges, for example, and you can see that we're dropping off to the right of the ridge here, the direction I'm moving my mouse, and we've got the pinks and the reds, which we would expect to be some type of an easterly direction. And we can confirm that by looking up here to see actually we're looking at north and northwest facing. So like I said, it can be confusing, but yeah, that's what if I turn that off and go back to our DEM view, you can see that we're looking at a bottom drainage here, which when you looked at that initially, it looks like it's a ridge top, but a lot of things are just the reverse on these layers of what they would seem at first. So again, it always helps to compare that with your relief and your contour maps to verify things. So this area here is a drainage in the bottom. Going up to the right is going uphill. And if we're going uphill to the right, we would expect that to actually be facing westerly, not easterly. So we would expect this area in here to be facing due west, as you can tell from the terrain. Let's go ahead and turn that back on. And you can compare the colors in here with the colors you have over here. The dark blues is due west, which you would expect. And we switch that back for a minute. You can see that this area in here is a hill going upward, is facing out to the north, and we can turn that on and we see red color in there, and red is indeed the north. So you can kind of confirm basically what the data is telling you. If you're like me, I always like to satisfy myself that the data is accurate by doing a couple comparisons before I just take it for granted. But I think after you do a few of these comparisons, you'll see that you could take it for granted that this aspect map is correct. And we now have colors on here that shows us the direction of a particular raster cell is facing, which can be very useful for a lot of modeling types analysis. For example, a field I'm familiar with is forestry, and I know that in general, trees will tend to grow a little bit better on slopes that face north and face east because you've got a little more moisture on those types of slopes. And so I might be doing some type of model where I want to look for a certain type of tree that likes more moisture, or look for trees in a primitive area that might have been growing without being harvested for a long time. I might expect to find larger trees in these areas that are facing north and east than I would find on the drier slopes, which would be westerly and southerly. So there's a lot of things you can do with this, from looking at wildlife habitat to just the physical terrain. For maybe you're wanting to put a road in and you want to avoid certain slopes that are certain steepness, you want to avoid certain aspects or use certain aspects, so forth. There's a lot of potential uses you can make out of this type of an analysis. So, and it's very easy to do. All of them come from the source map of the DEM that we started with. And these are just a few of the examples that you can do with those. I'm going to stop for now. You now should know how to create a DEM map, which will be included on the exams that are upcoming. You now know how to create a hillshade. You can set your transparency to view that hillshade. Turn that back on. And you can also create a contour map. You know how to set your intervals. You can create a slope and aspect map. And that gives you a lot of tools to work with from the DEM data. And again, I would encourage you to go ahead and experiment with laying some of your other vector-based data on top of these rasters, just to convince yourself that they are working correctly, that areas where you would expect drainages to be are drainages. The mountain peaks are where you would expect them to be. You might even load a DRG onto one of these. Remember, there's a good chance you'll have to reproject something, either get your 83 into 27 or 27 into 83. Usually you're going from 27 into 83 for your datums. You might create two versions of this DEM set of files, a 27 version and an 83 version to use in different circumstances if you like. But with the previous videos showing you how to do reprojection, you should be able to do that. And hopefully you've got some tools now to work with, and you're beginning to see how you can start to put all of these things together to build a comprehensive project. So here we just looked at the basics of building a DEM and a few of the types of layers you can create from that. And go ahead and give it a try. Experiment with it. Do both quads in the Yosemite Valley area and pull your DLG data into that and look at that. So I'm going to stop for now, and that will conclude this video.